In the CUBE missions, we are aiming for economically scalable, global quantum key distribution. Our first mission, QUBE-1 or just CUBE, is a pathfinder to test different payload and satellite control systems for their suitability for future missions. We are using a so-called CUBE satellite with a volume of only 3 liters. Let us have a closer look at the satellite, and especially the quantum sender payload from LMU. For that, we open up the satellite and pull out the payload. Besides a bunch of electronic components, you see an optical assembly at the top right part with an optical fiber leaving it. Zoom in and further, we see 4 laser diodes, microlenses, and polarizer foils. By selectively switching on either of the 4 laser diodes, we can choose if horizontally, vertically, diagonally, or anti-diagonally polarized light is coupled into a waveguide circuit. In reality, we switch the laser diodes 100 million times per second to transmit a key. That is actually also the main purpose of most of the electronics that you have seen. We need to prepare very short electrical signals with a high repetition rate to drive the laser diodes. This light is finally coupled into an optical fiber, which is connected to the optical laser terminal Osiris pointing towards Earth. As you have now seen the concept of one of our quantum key distribution sender modules, let us look at the actual device. Here you see a prototype of the module. Keeping in mind the edge length of the entire board of less than 9 centimeters, you get an impression of how small the optics really is. Remember, here are the laser diodes, microlenses, and polarizer foils, as well as the waveguide circuit and the optical fiber. During development, this module actually had a hard time as we needed to test it for space readiness. We bombarded it both with gamma and proton radiation. It was tested against vibrations and mechanical shocks. And of course, it was operated in vacuum while driving temperature cycles. As final tests, we placed a model of the satellite including all payloads at different remote locations. In those tests, we aimed at the optical ground station, where we placed our receiver unit to analyze the quantum states. Finally, you see here the fully integrated CUBE satellite featuring 2 quantum sender modules, a quantum random number generator, and an optical laser terminal. And now keep fingers crossed for a successful launch and operation of our satellite.